Hello everyone, welcome back to Dragonfly Engineering. So this week we're getting back onto the robot mounting bracket for the new molding machine in the clean room. This is the green robot that I've been talking about. So a couple weeks ago we started making the mounting bracket, which is this complicated 3/16 steel bent and welded structure. And we bent and welded the first component of this mount. The second component I've got loaded on the Haas mill here, because we need to machine a couple of holes for mounting, or drill some holes and then machine a clearance hole for a knob that unscrews or removes the hopper in the molding machine, as well as another hole for a air evacuation hose. Because the molding machine, when it's got molten plastic, it creates some fumes. So it's basically an accessory for this part. So I'll show you the model on the computer so you can get a refresh of what I'm talking about. But in the meantime, I've also loaded the second flat piece of 3/16 steel that we cut out in the last couple episodes ago. And I've got it loaded on the Haas TM1 mill on a soft table, which is basically just a sheet of plastic that's clamped into two vices. And I've found the tool location in this corner for the sheet metal. And we're going to machine a 5-inch hole here and like a 2-inch hole over here, and then drill some mounting holes for when we ultimately bend and weld this sheet metal plate into its form. Then we can mount it onto the molding machine. So let me zoom you in so we can take a look at the details of this setup. I don't know what these are called, but these triangular adjustable blocks are underneath the steel, and then I got more out here, and then this strap clamp, clamping the steel down to this guy. So this is kind of like a machinist jack, except that it's completely retaining the steel right here. So that should be good enough to hold it. All right, so I got the program loaded in the tool set. So we got a drill center, this 5/16 drill bit, and then the 3/8 roughing end mill that's gonna drill some holes and machine out the circle. So let's go ahead and fire this up. So menu and cycle start, and it'll do a tool change here. I'm gonna make sure nothing crashes. I'm gonna slow it down to enter, and then for this one I'm gonna run coolant since it's mild steel. Hopefully it'll pull out the back, but let's see. Okay, cycle start. There we go. Okay, and then we're going to start our tool into that drilled hole. I'm going to slow it down to make sure we're good. And it looks like we are. So it's doing a pretty good job. I could probably speed up. It sounded like it was having trouble clearing the chips. There, it broke free. I have a slight lead out on this tool path, but I don't want this thing launching on me. Here we go. Okay, so here's the first plug. Kind of a rough edge there from the roughing end mill. So that is the 3/8 roughing end mill with the serrated flutes, which made that bad finish, but real efficient mass removal. Oh man, it's stuck. If I can bust it off. There we go. That took care of that. All right, so I'm over here at the brake and we are going to finish marking the bend lines, and then I'm going to go ahead and bend this guy up so we can get this project done, so we can mount that robot. So let's go ahead and mark out our bend lines here. Okay, we're ready for the first back bend. There's 2 back bends on this part, and then the rest are the forward bends. And if you want to see more details about how I set this machine up, then you can see the previous episode about 2 weeks ago, where I went into more detail about setting the dies and the punch and everything like that. So we're just going to kind of plow through these bends and get this part done. So we're ready on the first bend on the back. So I'm going to go ahead and bring this punch down to the pinch position. There we go. And I'm going to load our stock in for our first bend. I'm going to hang the end of the structure off the end of the punch die here. I may have to remove the other one. Yeah, it looks like I will. Because this guy's got to go. I'll pull this guy out. And one of the viewers had mentioned that there's still a lot of gravitational energy stored in this top of the press brake. So he recommended sticking some uncrushable object in here when I'm fussing with it. So thank you for that advice. I'm going to stick this 2-inch block of aluminum in. That way, if I get my hand under it, then the brake is going to, for some reason a hydraulic line blows or something, the brake will bottom out on this aluminum block and keep my hand safe. But I also have the pump motor off just as extra precaution, and I don't want to ding my die too much, the V-groove die at the bottom. So I'll put a couple of shock absorbers in here. That's good. And then we'll just move this thing out of the way. Okay, so we'll pull this die out. And I'm going to have the same problem I had last week, where if I do this bend and this metal is overhanging, then it's going to warp in a weird S-shaped bend. So I actually have to move the die all the way over to the left so that this metal has a place to move when I execute the bend. So let's go ahead and stop again, and I'll reconfigure for that. Here I'm setting the new pinch height. Since I raised this V-groove die up by 1/2 inch to get extra travel for the overhanging plane to clear the bottom of the brake. So since I did that, I need to reset the height of the pinch and the height of the die in the controller as well, so it can calculate the 90-degree bend, or how much travel this punch travels into the V of the die. I think that's good. All right, so let's stick our stock back in. So this part back here is gonna actually travel down and not have a V shape, but this V is gonna cause this part of the plane to actually pivot down and in. So we need to clear that in the die setup. So now we're in the high force regime of the hydraulic press brake since we're at the pinch point. There we go. Okay, so you can see how the plane of the metal actually went down in there, and without raising up and creating this clearance in the die, I would have been some crazy S-shape planar curve in this portion of the metal. So anyway, so let's go ahead and bring the punch up while I'm holding the stock. And here is our back bend. Let me show that to you. Oh, here we go. So there you go. And it terminated, and then this part of the steel is still flat, which is nice. This may be a little odd for there's a little tab of metal on the end here, but I think it'll be okay. Okay, so go ahead and do this bend. When you got a big hangover of metal like this, you got to make sure that you're clearing, because this whole plane of 3/16 steel is going to shoot up 45 degrees, and you got to make sure your chin's not in the way. Just like that. Okay. And then I guess we can go ahead and do this other bend over here. I'm gonna hit this die now, so I gotta pull this die out next. Oh, you know what? I got the same problem over here. I got overhanging metal. So I need to send this die all the way the other way to have an edge here so that this metal doesn't get torsioned or S-bent. All right, so we're back, and I've moved the die all the way over. We're still on our spacer so that we cleared the edge of the bottom of the brake support, or the stage of the brake. And then we're gonna load and do our bend here. All right, so right now the light curtain is clear. The light curtain is about here. Yeah, right where my fingers are is where the light curtain prevents downward travel for the rapid move to the pinch position. So with all clear, I'm gonna hit down. And now we're at the pinch. Now I'll set this bend location. And these are just bends at the end of the sheet metal edge to help create a three-dimensional structural rib there to strengthen the entire weldment that we're gonna weld together next. All right, this looks good. I'm gonna move over a little bit, and I'm still gonna hold on and anticipate the part swinging up when I hit down. Just like that. I'll raise the punch. Oh, my angle changed a little bit, but that's not the end of the world. Oh well. Of course, my luck is I'll have to move the die to the other side again. But it's kind of hard to visualize this stuff. So sometimes you just got to deal with issues. Yeah, I have to shuttle the die all the way to the other side of the brake again. So I will be right back. Here we go. I'm gonna pull it out. There we go. Okay, so I had to shuttle the die over again. Then we'll load this bottom flange. So we got a square edge here, so we can check with the carpenter square. The more you check angles, the more accurate your final part is going to be. Let me go ahead and hit these back flanges. Ah, shoot. Yeah, I'm not going to be able to, because this flange is going to crash into the die if I try to bend these tabs. So I'm going to have to basically clamp in some some steel blocks and then hammer those final tabs over, or use the vise or something. All right, so I'm going to bring this down to the pinch position. There we go. And then I got to string this in through the end. If I can get it to fit, which I can. Oh, that's a tight pinch. Okay. So here we're looking at the end of the punch, and we need to clear this flange that's already bent in the sheet metal part. And I guess I didn't need the die to stop short, but it's better to have extra features just hanging off in space, because we could kind of booger up the edge of this tab in the V itself if my alignment isn't that great. But let's go ahead and bring down the punch all the way. And it may be like, oh, okay, I can still move it. That's good. All right, so we get the punch aligned there. So let me check squareness here. I probably do need to adjust it a little bit. Yeah, let me do one last sanity check. I'm gonna go nice and gentle on this one. Woo, yeah, we're getting close there. But I think we are just about at 90. I don't know if I can fit my square in there or not. I got half an inch to go. So maybe what I'll do is I'll put a protective piece of sheet metal so I don't scratch my brake. So I'm going to put this aluminum channel right here to help save my paint. You know, I got to keep things looking good, so that should help it. All right, so we probably will get some funny bending going on here, but let's go ahead and finish the bend. Maybe that was enough. Let's stick this square in here again. Yeah, that looks good. Okay, that's full bend. And this is actually kind of cleared, so I think we're good. I'm gonna raise the punch and make sure nothing's gonna get pinched. Like that. Then pull out our finished bent piece of metal. There we go. All right, so the next thing we got to do is bend these two tabs 90 degrees this direction. And I didn't have the infinite number of dies or orientations in the brake to make that happen. So fortunately though, we've got a nice bend termination point here and then a return flange here. So if we support this tab rigidly, we should be able to bend it manually. And to do that, I've got this old pipe, which has been through the ringer a few times. And I'm basically going to clamp this pipe onto this tab here and then just, you know, brute strength bend it. So let's see how that works out. All right, so hopefully this bend works. So I clamped the other end of the sheet metal onto the table. So let's go ahead and do our bend. Oh, my C-clamp's in the way. go. Nothing like leverage to fix problems. I'm binding up on my C-clamp. I can always hammer this home. Okay, here goes. Well, that'll have to do. The position is actually pretty close to where it needs to be. So I may just have to hammer that in a little bit. And what I got is this hammer right here, which may not be substantial enough. So well, I need a bigger hammer to bend that piece of metal, or that metal tab. So let's see which one we need here. We got the Stanley for $5-6 bucks. That's not quite right. Keep looking. It's definitely not rubber mallet. This is the hammer that I currently have, but it's too small. I need more like a sledge. Oh, here we go. Yeah, I think maybe this is the one. 4 pound with like a nice edge bending tip there. So I think we're gonna go with that one. All right, I'll meet you back at the shop. So I'm talking about right there. This should do some damage. Not sponsored, by the way. Okay, actually I may be able to just use the body of the sheet metal itself as the other bending break stress concentration spot. So let's just bend this and see what happens. Oh yeah, that was pretty easy. And it looks reasonably lined up as well. So that wasn't so bad. I could sharpen that bend up a little with this sledge here. So now if I loosen this clamp, we have our flange, which isn't too bad. Okay. And then this one over here is still a little funky. And I did a few more kind of checking with the square on my handy dandy welding table, which is a pool table with a couple sheets of plywood over it until I get the final table built. So bear with me on that. But the next thing we need to do is to do these final little return flange bends at the top. And again, I didn't bend these because I don't have an infinite set of punches and dies for the brake. So what we're going to do is I'm going to use the die grinder to slice a score line into these 3 flanges, and then we're going to bend them and then fill in the scored bend with a weld, which basically is almost as strong as the original CNC, or the straight bend off the CNC brake. Yeah, that's going. Don't break off, please. All right, here goes. All right, so now what I'm going to do is try to cut a kind of a V shape into this original score line, so that, you know, when we bend this guy 90 degrees, the V shape will close out. All right, let's see what happens. Oh yeah, we got a good bend going. Now if my V wasn't wide enough, then basically I'm going to be stretching and maybe ripping this steel apart. Feels like it's bottoming out. But what I can do is go through on the backside and cut out a new clearance since I've pinched this steel closed probably. And we can keep working it that way until this flange drops down 90 degrees. All right. Yeah, that doesn't want to move. Well, looks like I might have to do more clearance or pull out that huge hammer that I bought yesterday. Let me cut some more, and I may hammer it home. We'll see. Looks like I need to cut more off the, at least on this side, the back side of the steel to line this flange up with the final bent. So I can drift my bend by cutting more steel in the back. All right, so let me get myself back into practice on welding. I'm definitely not a career welder or heavy steel fabricator, so bear with me. But what we're gonna do is weld in this corner that we bent and this one, and I may have to grind off some of the oxide layer, but we're also gonna weld in this corner as well. After that, we're going to start tacking together all the various pieces and squaring everything up, and then do the final stitch welding of everything. So let's get going. We're using a MIG welder with just flux core wire, so nothing special. It seemed like it was wanting to burn through, but I'm also splitting out the top of the bend too on the other side opposite this corner. But you know, let's just keep moving forward. All right. I'm the kind of welder that requires copious amounts of grinding after welding, so. And I'm bridging across these two pieces of steel and kind of filling in with swirl pattern. And then up here I'm just going to add some more meat to this corner. All right, so we're going to take a look at the fitment of all of these various pieces that we've cut out and bent. And you can see, let me see if I can do this with one hand. So here's one piece that we bent last week, or a couple weeks ago. This may be tricky to do with the GoPro in one hand. But this piece fits in like that. And then this piece, which used to be attached to this piece, but then we decided that we can't bend it. So I went ahead and cut right here, this cut. This guy fits in with the nestled flanges down at the bottom, like so. Now, of course, I'm gonna have to position all these parts correctly using the carpenter square here and tack weld it all in. But I do believe that I have a problem with this corner right here. This angle is deviating from this angle. And no matter how I arrange it and hold it, there's still like basically about a 1/4 inch extra material here. So the next thing that's required, and I'll probably do a time lapse on this, is basically to set all the corners and the positions using the square and tack weld everything in place to make sure that all these bent pieces fit correctly. And then we'll stitch weld everything together after that. So I think I'll time lapse all that. So let's do it. I've laid the thing down, the weldment down on its back so that I can kind of bend this triangle in, because I've got kind of a nasty gap right here. You can see there's probably quarter inch here down to nothing here. And the back panel, this thing right here, is a little out of square, but not bad. So I think I'm basically just gonna split the difference on that and then see what happens. But I also got this bar clamp here because I've got this flange, or this bend is kind of sticking out a little too far. So I'm gonna clamp it in about 1/8 of an inch this way. I'd already bridged it, so I'm just kind of reinforcing that tack. Here's like an 1/8 inch gap. So we'll see how square the back is. Let me get this off of here. If our tack keeps that. Whoop. Okay. So this is straight and square, then that'll be what we need. Yeah, that looks pretty good. So this is our structure tack welded in place. As it turns out, I didn't need to do anything with cutting this edge. When I squared up meticulously each corner, then this came into line, so that's kind of nice. Let me get the GoPro so we can kind of do a close-in tour of our weldment, or our tacked weldment. Okay, so basically this is the edges of our weldment. You can see I tacked right there in the middle, and we've got good triangles to fill with weld. There are some air gaps, but the weld will fill that just fine. And then over here was the area I was concerned about, but it actually kind of came into line, so that's kind of nice. It actually matched the CAD model. Then over here is the other corner. There's a little bit of an air gap there as well. And then starting of the structural flanges up here where the robot is going to mount on this surface right here, facing us. Probably the worst gap is right here. There's like about an 1/8 inch gap there. You can see this tack weld. I basically tried to spring and push this structure more in line with its mating feature, but you know, that's what we got. And then here we're going to weld along and fill in this joint between the two pieces of bent steel. Looking at the bottom, you know, that flange is touching the surface. This flange back here is a basket case. I actually bent it too tight when I was using that big floor vise. So I'm probably going to put build up a bead of steel below this guy and then grind it flat. So this will be the adjusting corner to get the rest of the corners flat. But you can see over here how this flange is flat against the table. And then in here, I kind of have a little bit too much of a gap here, but I can weld that shut. But this flange is good. And then back here, this tab flange is good as well. So pretty happy with how everything worked out. And then this final edge here is coincident to the table as well. As you saw, I had to cut another basically thickness of the 3/16 steel off to get this edge to work out. I think there was basically some issue with the bend radius, you know, because this sheet metal brake is only 44 tons. And I don't think I was getting the true natural bend for this heavy gauge steel. So basically my bends were bigger. Thus, you know, this bottom flange was sticking out further. So I basically solved that problem by cutting basically one width of the steel off the top. So the next step is to basically stitch weld all these seams together. And that'll just be a whole lot of welding. I'm probably going to move around to different areas of the weldment so I don't get like funny, you know, draw and shrinking of the welds and then knocking the squareness of this weldment out. So Okay, here's where we are. I did most of the stitch welding. I put a couple of layers of welds here and I was trying to blend these two facets together, and I'll probably wind up doing Bondo here. You know, the the scourge of the amateur welder is Bondo. So I'll probably clean that up with Bondo and then this joint here. But all in all, I'd say we're pretty solid. All right, well, here it is. I've temporarily placed the weldment here on top of the molding machine where the robot is gonna bolt horizontally and then reach down into the work cell area right here. And I checked clearance and it looks like we're good other than one issue. There's a door stop, which is basically a vertical sheet of metal back here. And it's currently interfering with the proper seating of this whole weldment. Yeah, so there's this silver piece of metal right here, which originally was used to prevent the door from swinging all the way back and falling against the back of the molding machine. But this piece of metal right now is interfering with the flange on the return flange on the weldment. The door does open, but this handle, which I anticipated was going to be too tall, does hit the top here. So I'm either going to get a new handle or I'm going to machine off about ½ an inch on this handle, or just get rid of the handle altogether, because I can, this is the handle right here, I can open this hatch without the handle, but it's a little fussy. I may also put a ball handle and stick it where the hole for this handle is. But anyway, yeah, I definitely have clearance for some sort of handle. Looking at the back, this is the clearance hole that I machined such that this knob would clear. And right now I've got the whole weldment is up, sitting up about maybe 3/4 of an inch. And I made this hole oversized so that it creates less of a pinch hazard. You know, because you don't want your hand in here and then have the carriage unit move in and out and actually kind of get your hand cut or crushed. So it's still a pinch hazard, but it's much less of a hazard because, you know, your hand can still fit in here. The injection unit is completely forward right now, and there is a little bit of a pinch zone up here as well. You know, if I had employees working in here, then it may be an issue. But there's going to be robots running around in here, so having pinch zones is not as big of a deal because the whole area is a hazard. So, thanks for watching, and I'd like to extend a special thanks to my patrons who help make these shows possible, and all of my subscribers and viewers as well. And next week, I will see you with the conclusion of the robot integration, and also happy holidays and Merry Christmas and all of that. So, thanks for watching. Goodbye.